Whenever an object is heated, energy is transferred to its thermal energy store, and its temperature increases. The process of heating, though, can take place in three different ways, depending on the medium involved. For solids, heat is transferred by conduction. In fluids, it's via convection. And to get through empty space, heat has to be transferred in the form of radiation. Let's start with conduction. The key idea behind conduction is that vibrating particles transfer energy to neighboring particles. To understand how this works, let's imagine that you were heating one end of a piece of metal with a Bunsen burner. And imagine the piece of metal as a series of particles. As the end of the metal is heated, energy is transferred to the metal, or more specifically, is transferred to the kinetic energy store of the particles at that end. This causes the particles to vibrate faster, and so they collide with their neighboring particles more often, and with more energy. As the collisions transfer kinetic energy, the neighbours will also vibrate faster, and collide more with their neighbours. And as this process repeats, energy is passed along the piece of metal, until in the end, the heat is spread out evenly, and it will be pretty much the same temperature everywhere. Now, the reason that conduction occurs mainly in solids is because the particles in a solid are held together really closely, which means that there's lots of collisions that pass on the energy. Whereas in liquids and gases, the particles are all further apart, and so they don't collide as much. Exactly how well objects transfer energy by conduction is known as their thermal conductivity. Metals have a high thermal conductivity and transfer heat energy rapidly, whereas plastics have a low thermal conductivity, which is why we use them as insulators. And pretty much all fluids have a low thermal conductivity. Convection, on the other hand, occurs mainly in fluids, and remember, fluids can refer to anything that can flow, so both liquids and gases. Because the particles in fluids aren't fixed, once they're heated and they gain kinetic energy, they all move around faster. By the process of random diffusion, this will cause these more energetic particles to move away from the warmer region towards the cooler region. And overall, this means that the higher energy particles in the warmer region are a lot more spread out than those in the cooler region. So effectively, the fluid in the warmer region actually expands as it heats up, and so becomes less dense than the cooler fluid. To understand how this works in real life, let's imagine that we had a container of fluid, so that could be either liquid or gas. As we heat the container, the following things would happen. First, the particles near the heat source would gain kinetic energy and spread out, becoming less dense. Because they're less dense, these particles rise above the colder, less dense particles above them. And at the same time, these cooler particles sink down and take their place. Whilst this is happening though, the hot particles would lose their energy and cool down, and the cool particles now at the bottom would heat up. Because of this, the cycle would keep on repeating for as long as the fluid was being heated, and we call this cycle a convection current. We actually see these convection currents all over the place, from oceans to inside buildings, where radiators warm the nearby air and set off the cycle. On the other hand, to reduce convection, we need to stop the free flow of fluids, which is all we're doing when we sleep under a blanket at night, which is stopping the warm air from escaping. What conduction and convection have in common is that they both involve particles gaining kinetic energy. It's just that in conduction, only the energy is transferred between the different particles, whereas in convection, the particles themselves move. However, heat energy can also be transferred without particles, which means it could travel through a vacuum. This happens when energy is transferred by radiation, and specifically when the energy is carried by infrared waves. All objects constantly absorb and emit radiation, and in reality they do both at the same time. Importantly, the hotter the object is, the more radiation it emits. This is why it feels hot to put your hand over a barbecue, even if you're not touching it. The very hot metal and coal is emitting infrared radiation, which is absorbed by your hand. We take a closer look at infrared radiation when we cover the electromagnetic spectrum. Anyway, that's all for today, so hope you enjoyed this video, and we'll see you next time.